In this video, we'll look at some examples of functions and determine if the function is even or odd. And if it's not even or odd, then we would say it's neither even nor odd. Now, just a really quick reminder about even and odd. What I like to think of is the most basic even function and the most basic odd function. And the most basic even function is going to be f of x equals x squared. And we'll notice about f of x equals x squared. We'll notice about f of x equals x squared that f of the opposite of x just gives us back our x squared. F of the opposite of x gives us back our f of x. Let me make it a little more generic by writing f of x. So in other words, if we look at the graph, we can see that when x is -1 or x is +1, we get the same y. Whatever happens on the right side of the function is identical to what happens on the left side of the function, where we're just defining left and right as cutting it down this line of symmetry, which is the y-axis. So when a function is even, we can see that it has y-axis symmetry. But what we do to demonstrate or show that a function is even algebraically is we replace the x with the opposite of x, and we show that we get that same function back. So when I replace the x with anything here to the left of left of x equals 0, any negative values, we get the positive value back. Or if we put something in a positive x, we get the same thing as we would have with putting in its opposite. And then let's look at an odd function. We say a function is odd, and we could start by thinking of the most basic odd function, f of x equals x cubed. And what happens with f of x equals x cubed is that if I replace the x with the opposite of x, what I get back is, so if we let x equal 1, now instead try x equals -1, and what do I get back? I get the opposite of f of x. So f of the opposite of x is equal to the opposite of f of x. And we can see this with the x cubed function. The symmetry, it's as if we look at symmetry across the y-axis, so we'd come over here, and then reflect it about the x-axis, so we get this piece down here, and that's called symmetry about the origin. So it's symmetric with respect to the origin. When we reflect on the x-axis and on the y-axis both, that is symmetric about the origin. Let's look at this algebraically and determine how to know, just algebraically, whether we have symmetry and whether it's even or odd. So what I'm going to do in every case is I'm going to replace the x with the opposite of x. So in place of x cubed, I have the opposite of x cubed. And if I expand that, the opposite, 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 we end up with the opposite of x cubed, right? So our three x's, x times x times x, there's x cubed, but a negative times a negative times a negative would be negative. And then negative 6 times the opposite of x would be positive 6x, because the negative times the negative is positive. Notice that we've got the opposite of x cubed and the opposite of negative 6x. So what we can say is that this is equivalent to the opposite of f of x. Once again, why am I saying that? Because we've got this positive x cubed is now negative, and this negative 6x is now positive. So we're saying that the value of f of the opposite of x is always the opposite of the value of f of x. So this is odd by definition. And so it has it's symmetric with respect to the origin. Let's look at another example. And in this example, we've got f of x equals 3x to the 6th plus x to the 8th plus 3. So what I'm looking for is f of the opposite of x. So I'm going to just rewrite my function, but in place of every x, I am putting an empty parenthesis, and I'm going to go in and fill all those empty parentheses with the opposite of x. Do you notice I'm not saying negative? The reason I'm not saying negative x is because if the value of x is a negative number, it doesn't make sense to call it a negative 7 or so on. So I'm just saying the opposite of x so that we're clear whether x itself is positive or negative. But f of the opposite of x is going to be 3 times this opposite of x to the 6th. And if we expanded that, we had this negative x, or opposite of x, I should say, 6 times, you see what's going to happen. It's going to be positive, isn't it? 1, 2, those pair up to be positive. 1, 2, they pair up to be positive. And then 2 more pair up to be positive. So we have, this would be, the 3 isn't changed, but 3 times x to the 6th. So f of the opposite of x is going to start off being 3x to the 6th. And we can see the same thing's going to happen with this next one. Because it's an even exponent, it's going to come out being positive, right? And this 3 is just a constant, so it's not affected at all. So notice that what we've got back is our 3x to the 6th plus x to the 8 plus 3, or f of x. So in other words, f of the opposite of x is equal to f of x. So that's even, and even functions have y-axis symmetry. Let's look at just one more example. And we could, again, what we're going to do is replace the x with the opposite of x. And every time I do that, I'm going to simply start by having these empty parentheses. So x to the 6th, we're replacing x with the opposite of x, minus 3 times x, replace the x with the opposite of x. And here we've got an even number of negatives, so it's still positive, negative, and even number of negatives, 3x. So we have x to the 6th is still x to the 6th, but this negative 3 times x is positive 3 times x. So notice that that's not our function back. Our g of the opposite of x doesn't give us our function back. Our g of the opposite of x doesn't give us g of x. And it doesn't give us our opposite of g of x either. So we would say that this one is neither even or odd. So we could say that it doesn't have some symmetry with respect to the y-axis or the origin. Even and odd can become really easy for some students after a little bit of practice, but make sure you jump in and do the examples, try it out a few times, that process. But remember, what we do to show algebraically that a function is even or odd is we replace the x with the opposite of x and then determine if we're getting the function back or the opposite of the function.